Hello, and welcome to Computers and Courses and Subnetting.us on the World Wide Web. And today we're going to take a look at binary numbers. We're also going to take a look at decimal numbers. And you're going to see why this is so important for us to take a look at binary and decimal numbers just around the same time. So, binary numbers are made up of ones and zeros, zeros and ones. Decimal numbers are made up of the numbers 0 through 9. We have binary and we have decimal. When we go ahead and write out a decimal number, we're going to have something that everyone should be familiar with, a number such as 472. And that number is made up of the part 400 and the part 70 and the part 2. And they're all added up together. Now you're probably thinking that I'm really oversimplifying this, which is fine. But we're going to really see why this is useful in just a couple minutes. So, if we take this one level deeper and we take a look at these numbers 470 and 2, this is the number 4 times 100 plus 7 times 10 plus 2 times 1. All right, 472, we got that. 400 plus 72, we got that. 4 times 100 plus 7 times 10 plus 2 times 1. We got that. This number and this number and this number are all part of our base 10. "100" can also be written as 10 to the power of 2. 10 can be written as 10 to the power of 1. And 1, this line's just a little too long there, and 1 can be written as 10 to the power of 0. So 4 times 10 squared, or 10 to the power of 2, plus 7 times 10 to the power of 1, plus 2 times 10 to the power of 0. These are all the same thing. This is a 2, this is a 2, this is a 2, this is a 2. We're going to show you another example of this in just a couple minutes. So we have 400 plus 70 plus 2. And if you're uncertain about something like this, 10 squared equals 10 times 10. Okay, so we have 472. So I just had to pause the video there for a moment, so sorry for jumping around. And let's go ahead and just bring this thing down. Let's take a look at a slightly easier problem. Let's look at the number 37. Break this down into 30 plus 7. 3 times 10 plus 7 times 1. 3 times 10 to the first power plus 7 times 10 to the 0 power. 10 to the 0 equals 1. 10 to the 1 equals 10. 10 to the 2 equals 100. 10 to the 3 equals 1000. So as you see here, when I have the number 37, I have a ones place, I have a tens place, I have a hundreds place, and so on. Thousands place. So if I have the number 4,137, this again could just get expanded. 4,100. Okay, so let's take a look at another example here. Three thousand 3,785. We have a 3 in the thousands place, a 7 in the hundreds place, an 8 in the tens place, and a 5 in the ones place. 3 times 1,000, 7 times 100, 8 times 10, 5 times 1. 3 times 10 to the third plus 7 times 10 to the second plus 8 times 10 to the first plus 5 times 10 to the 0. Okay. 3,785, 3,785, 3,000, 1,000, 70, or 700, 80, and 5. That's a 1, that's a 10, that's 100, and that's 1,000. These are decimal numbers base 10. All right, I'm going to show you one more thing, and we're going to wind down this video and go over to the next step, which is going to be binary. But a number, x to the 0, is always equal to 1. 10 to the 0 equals 1. 9 to the 0 equals 1. 400 to the 0 equals 1, and so on. And let's just take a quick look at why something like this is true. So if I have a number such as 3 to the power 3, which equals 9, and I have a number 3 to the power of 2, and that is equal to 6. Okay? Three cubed, this is not 9. That's a mistake. And this is a mistake. So let me just roll this on for a second. if I have numbers 3 cubed and 3 squared, this is the number 27, because this is 3 times 3 times 3, which is 9 times 3, which is 27. And this is 3 times 3, which is 9. So if I have 3 cubed over 3 squared, this is the same as saying 27 over 9, which is equal to 3. 27 divided by 9 is equal to 3. Okay, the other way of writing something like this is 3 to the power of 3 minus 2. And this, you actually do subtraction here, so that equals 3 to the 1, which is also just simply 3. If we take a quick look at the next step here, if I have 3 to the 3 over 3 to the 3, okay, I know that this is equal to 27 over 27. And any number divided by itself is 1. But we can also write it as 3 to the 3 minus 3. This here, which is the same as saying 3 to the 0, which is the same thing as 1. So any number to the 0 power equals 1. X to the 5 for x to the 5 is x to the 5 minus 5, which is x to the 0, which equals 1. Next video, binary. Okay, thank you for taking a look at this quick video on decimal numbers and how they're going to relate to binary numbers. And we will catch up with you on the World Wide Web at either Courses in Computers or at subnetting.us. Thank you, and you have a wonderful day.